Hello there and welcome back. We're continuing today with fluid mechanics and we're going to talk about Venturi meter in combination with a manometer, so stay tuned. Before we move forward, I would like to remind all of you with an engineering degree from outside of the United States, if you are interested in evaluating your education in this country and you need a bit of help with that, click the link below and download the step-by-step guide for free. Now let's move on with our example. A horizontal Venturi meter with a diameter of 15 centimeters at the throat is installed in a 45 centimeter water main. A differential manometer gauge is partially filled with mercury. The remainder of the tube is filled with water and connected to the meter at the throat and inlet. The mercury column stands 37.5 centimeters higher in one leg than in the other. The specific gravity of the mercury is 13.6. Neglecting friction, the flow through the meter is most nearly. Let's first look in the FE handbook for the formula for the Venturi meter. We can just do a search, and here it is. So we're going to have to write this formula down. This is what we're being asked to calculate, volumetric flow rate. CV is coefficient of velocity, A, cross-sectional area of flow, P is the pressure, gamma is the density times the G, Z1, Z2 is elevation of Venturi entrance, elevation of Venturi throat. Okay, let's go back and write this formula down and then see what else do we need to calculate. Then we have multiply times square root out of 2G. And then we have times P1 over gamma plus Z1 minus P2 over gamma minus Z2. Let's first talk about the Z1 and Z2 and acknowledge that the elevation is the same, right? If we go back, they're explaining Z1 and Z2 are the elevation of Venturi entrance, elevation of Venturi throat. So we have Z1 and Z2, they're at the same level. So here, these two are gonna just go away. And then let's start and write this formula again with the remaining. So we're gonna have this member unchanged. A2 over 1 minus A2 over A1 squared, that's square root of that. And then we're going to have 2G multiply by, and we can write this as P1 minus P2 over gamma. Here you go. Now, again, let's calculate the P1 and P2, P1 minus P2. Let's just calculate the P1 minus P2 and treat this as a single manometer and calculate the P1 minus P2. So I'll do this right here. If I have a video about calculating the pressure in the manometer, go back and watch that video. Right now, I will just go straight and calculate P1 equal to P2, right? And from here, we're right here. We have to go all the way down to this level. We know the age is 37.5 centimeters. So going downwards, the pressure increases. That means we're going to have gamma mercury, because this is mercury we have here, times age. We're going to call this age. And then, as you know from the manometer video, when we have the same fluid within this tube, we can jump to this side because the pressure at this point and at this point is the same. So we don't have to calculate the pressure all the way here. So now we're going to jump here and we're going to calculate the pressure from this point all the way to point 1. So we're going to have going upward, you know that the pressure decreases. So we're going to do minus. We have gamma water multiply by the same H. And from here, we can do P1 minus P2 equals to gamma mercury minus gamma water times H, or we can also write it as density of mercury minus density of water times GH. So this is our P2 minus P1 minus P2. So let's go back to this formula here. I will make this right here like that. Make a star, right? This is the star continuation. So we'll, maybe it's a good idea to discuss every single term so we can right away, oh, you know what, actually, let's calculate the areas because we're going to need the areas. So based on the formula of the Venturi meters in the FE, A1 and A2 are noted here. So A1 is the area of the bigger opening, and A2 is the area of the smaller opening. So let's calculate that. We'll do A1 equals 2P times the diameter of the bigger opening is 45 centimeters. So I'm going to do transform into meters right away. Squared over 4 equals, and if you calculate this, you should get 0.159 meters squared, and A2 equals to pi times 0.15 squared over 4, and you should get 0.0177 meters squared. Now let's go ahead and talk about CV. So coefficient of velocity, it's called, and this coefficient is given in FE book. Let's find it here somewhere. Coefficient of velocity, you're given a few values. So right here, the coefficient of velocity, we have about this case, but so our coefficient of velocities, we can take it as 0.98. The point is to know is that when you have, usually in Venturi meters, the transition is very smooth, so there's very little head loss. So the coefficient of velocity is very close to 1. So we can take it 1 or 0.98. It's not a big difference. So I'll do 0.98. You can also do 1. See what's the difference. Okay, what else? We know areas, we know G, we have P1 and P2, we have this. Okay, so let's go ahead and calculate this farther. I'm gonna go down here because I feel I have more space, so I need, okay. So this flow equals to 0.98 times A2 to 0.0177 over square root of 1 minus A2 which is again 0.0177 over 0.159. Of this squared multiplied by square root of 2 times, and G is 981 times, for P1 minus P2, we have gamma mercury, which we have to calculate. We are given the specific gravity of mercury, which is equal to 13.6. From here, what we know is that, let me show you where the formulas are. So I want you to be aware what I'm getting all this from. So right here at the beginning of the fluid mechanics section, at the beginning, you're given the specific gravity of any fluid is gamma fluid over gamma water, or density of that fluid over density of water. So let's go back here and say we need the density. So let's work with the densities. Density of mercury over density of water equals to 13.6. From here, density of mercury equals to 13.6 times 1,000, which is density of water, kilograms over meter cubes. From here, results density of mercury equals to 13,600 kilograms over meters cube. A little bit messy, I know, but I hope you're following me. Okay, let's go to the formula and substitute. Density of mercury, 13,600 minus density of water. Just gonna, okay, times. And here, let me just do something up here. If you look here, we have density of water times G. And then once we substitute this P1 minus P2 with this, these two G's, they're going to disappear, right? They're going to go away. So I'm going to be left with age here, which is this age is given, it's 37.5 right here. And it's centimeters, we have to transform it into meters. So I'm going to be 0.375 meters. And we divide by 100 because 1 meter has 100 centimeters. Now at the bottom, we're only going to be left with density of water. And again, I hope you followed what I said. P1 minus P2, which we have here, equals to density of mercury minus density of water times G times H. And if we would have written this here, I just don't want to write it twice. This G and this G, they're going to go away. So that's why we, at the bottom here, we're only going to have density of water. Okay, so now let's do the calculations and see what we get. Okay, so let's start from here. I'm going to start from here. I hope you're using your calculator to practice using it and knowing every single aspect of it. So I'll do 13,600, 1,000 minus 0.375 multiply 2 multiply 981 multiply 1,000 divided square root of that. Enter. And now I'm going to leave this number in my calculator. I'm going to go to this part, and I will calculate 0.98, 0.0177 multiply enter, and then 0.0177, enter, 0.159 divided square, minus, this has a minus sign, 1 plus, and then we have the divided, all right, and then we're going to multiply these two. Okay, so I get 0.169. Okay, 0.169, which is meter cubes over second, is approximately, let's see what is the answer here, which is approximately 0.17 meter cube over second, and is B. That's it for today. I hope you found this video helpful. If you did, don't forget to subscribe and give it a like, because this helps people like you find me. Also, if you have any questions about any of my videos or about anything else FE related, please don't hesitate to leave it in the comments below. Keep up the good work on practicing the FE problems, and I will see you next week.